Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the substrate structure. The compound shown is 3-bromo-3-methylheptane. The carbon-bearing Br, C3, is quaternary in terms of substitution. It has a methyl group, a propyl group on one side, C4C5C6C7, i.e., a butyl chain, and an ethyl group on the other side, C2C1 plus Br. More precisely, looking at the structure, the central carbon has Br, one methyl branch, and is part of a chain. Let me reread. The structure shows a carbon with Br that has a 2-carbon chain on the left, ethyl, CH2CH3, and a 3-carbon chain on the right, propyl, CH2CH2CH3, plus a methyl group. So the compound is 3-bromo-3-methylhexane. Actually, re-examining, the left side shows tilde 2 carbons, making it an ethyl group from the Br carbon, and the right side shows tilde 3 carbons, propyl. With the methyl branch, this is 3-bromo-3-methylhexane. Moving on to the next step. Identify beta carbons for E2 elimination. For E2, the base abstracts a beta hydrogen, antiperiplanar to Br. The beta carbons are those adjacent to the carbon-bearing Br, C3. C2, part of the ethyl group on the left, CH2 with 2 H's. C4, part of the propyl group on the right, CH2 with 2 H's. The methyl group carbon, CH3 with 3 H's. Moving on to the next step. Determine E2 products from each beta carbon. Elimination toward C2 gives 3-methylhex-2-Na. C2 is equal to C3 double bond. C3 is trisubstituted, methyl, propyl on C3 side, ethyl remnant. The double bond C2 is equal to C3 has substituents, on C3 side is equal to methyl and propyl, N-propyl, on C2 side is equal to H and H, from the original CH2. Weight C2 originally has 2 H's and connects to C1, CH3. So C2 is equal to C3. C2 bears H and CH3. C1, C3 bears methyl and N-propyl. This gives E and Z isomers, CIS trans. That's 2 products. Elimination toward C4 gives 3-methylhex-3-Na. C3 is equal to C4 double bond. C3 bears methyl and ethyl, C4 bears H and ethyl, C5, C6. C3 side, methyl and CH to CH3, C4 side, H and CH to CH2. Weight C4 connects to C5, C6, ethyl if hexane. So C4 bears H and N-propyl minus 1 is equal to CH to CH3, if hexane, or CH to CH to CH3. For 3-methylhexane, C4 has CH2, C5 has CH2, C6 has CH3. So C4 is equal to C3. C3 has methyl and ethyl, CH to CH3 from C2, C1, C4 has H and propyl, C5, C6. No, C4, C5, C6 is equal to ethyl from C4. This alkene also has E and Z isomers. That's 2 products. Elimination toward the methyl group gives 3-methylene hexane, exocyclic type, terminal is equal to CH2. This is CH2 is equal to C, chain, specifically methylene hexane. The product is 3-methylene hexane, CH2 is equal to C, CH to CH3, CH to CH to CH3. This has no EZ isomerism, one substituent is equal to CH2. That's 1 product. And for the final step, total E2 products is equal to 2 plus 2 plus 1 equals 5. Why other options fail? A. 3 undercounts stereoisomers. B. 4 misses one stereoisomeric pair or one structural product. D. 6 overcounts. Therefore, the correct answer is C. Therefore, the correct answer is option C.